Hey everyone. All right, today we're jumping into a topic that can look, well, pretty intimidating at first, or inequalities. But what if I told you there's a super simple trick that basically splits one hard-looking problem into two super easy ones? Yeah, for real. Let's dive in.
And that's really the big secret here. You're never actually solving one big, complicated problem. Nope, you're just solving two completely separate, much simpler problems. That's the whole game. So, let's see what that really means in practice.
Okay, so let's break it down. Think of it like this. You've got two completely separate math problems. They're on their own little islands, right? They have their own solutions, they don't talk to each other, they don't interact at all. The only time they come together is at the very end on the same graph, where we show both of their answers. They're basically just roommates on the number line. Okay, so what's the official rule? Well, when you see that little word "or" sitting in the middle of a problem, think of it as a VIP pass. A number gets to be a solution if it makes the left side true or if it makes the right side true. It doesn't have to work for both. Just satisfying one of them is enough to get into the solution club.
And this is my favorite part, the visual. Most of the time, the graph of an OR inequality looks like it has wings. You've got these two arrows flying away from each other in opposite directions. It's such a great picture to keep in your head. When you think OR, think wings.
All right, so how do we actually do this? How do we tackle any OR problem you see? Well, there's one simple, foolproof rule, and we're going to call it the divide and conquer strategy. Super simple.
And really, it's as easy as it sounds. 4 steps. First, you literally draw a line down the middle of your paper. Boom, you've split the problem in two. Second, you solve the inequality on the left. Third, you totally ignore the left side and solve the inequality on the right. They are two different universes. And finally, you just take both of those answers and plot them on the same number line. That's the whole thing.
Okay, enough theory. Let's actually put this divide and conquer strategy to the test. We're going to walk through 3 different problems, a basic one, an intermediate one, and then a kind of tricky special case, just to show you how powerful this simple rule really is. All right, here we go. Example 1. This is our first mission. We've got x plus 4 is less than 1 on the left, and x minus 3 is greater than 2 on the right. And right there in the middle is our key word, OR. So let's divide and conquer.
Okay, step 1, draw that line. Now let's just focus on the left side. To get x by itself, we just subtract 4 from both sides. That gives us x is less than -3. Cool. Now forget that ever happened. Let's jump over to the right side. Here we just add 3 to both sides, and we get x is greater than 5. See? What we did on the left had absolutely zero impact on the right.
And that's it. That's our answer. We just put the two pieces back together with the word OR in the middle. So x is less than -3 or x is greater than 5. See? Not so bad, right? All right, time to level up. Example 2. Now this one looks a little beefier, right? Each side is a 2-step problem. But, and this is the best part, our divide and conquer rule doesn't care. It works exactly the same way. The strategy does not change even if the problem looks more complicated. So let's do it again. Focus on the left, subtract 1 from both sides. That gives us 2x is less than or equal to -6. Then divide by 2, and we get x is less than or equal to -3. Done. Now let's hop over to the right side's universe. Add 2 to both sides. That gets us 3x is greater than or equal to 12. Divide by 3, and we're left with x is greater than or equal to 4. 2 separate problems, 2 clean solutions. And just like before, we just put them together for our final answer. Same exact process, just a tiny bit more algebra. See? The divide and conquer strategy holds up, no problem. Okay, now for our advanced example. And this one is kind of tricky because it looks so simple. We have x is less than 5 or x is greater than 0. Now, before we even do any math, just try to visualize this on a number line. Picture those wings. Where would they go? So, did you picture it? Think about it. The first wing, x is less than 5, starts at 5 and goes left, forever. The second wing, x is greater than 0, starts at 0 and goes right, forever. Well, what happens? They overlap. In fact, they overlap so much that between the two of them, they cover the entire number line. Pick any number at all. I guarantee you it's either less than 5 or it's greater than 0. So the answer here is everything, all real numbers. Okay, before we move on, I want to talk about the number one trap that people fall into with these problems. It's a super common mix-up, but it can really throw you off. We have to make sure we don't confuse OR with its evil twin, AND.
AND is super strict. For an AND problem, a number has to make both things true at the same time. So look at this. Can you think of a number that is less than 2
and at the same exact time is also greater than 5? No way! It's impossible. That problem has no solution. But OR is chill. OR just needs one part to be true. Is the number 1 a solution? Well, is it less than 2 or greater than 5? Yeah, it's less than 2, so it's in. What about the number 10? Is it less than 2 or greater than 5? Yep, it's greater than 5, so it's a solution too. That's our wings graph.
So you might be thinking, okay, cool, I get it, but when am I ever going to use this? And that's a fair question. But the truth is, you use this OR logic all the time in the real world, probably without even noticing.
I mean, have you ever seen a sign at a movie theater or maybe a museum that says something like this? This is a perfect real-world OR problem. To get that sweet discount, your age has to be less than 12 or your age has to be greater than 65.
Let's run the numbers. Say you're 10 years old. Do you get the discount? Yep, because you passed the under 12 check. What if you're 30? Nope, you're not under 12 and you're not over 65. You fail both checks, so no discount for you. But what if you're 70? You fail the first check, sure, but you pass the second one. And since it's an OR rule, passing one is all you need. You get the discount.
So really, the big takeaway here is that this isn't just some random algebra problem. It's a fundamental way of thinking. The next time you're just out and about, keep an eye out. You'll start noticing OR logic everywhere, in special offers, in rules for a contest, maybe even traffic laws. So think about it. What other OR rules do you follow every single day?